Hi, everybody. So, as Noah mentioned, I'm Adrian Herbez. I make games and interactive stuff, much of which has some amount of procedural generation to it. I also make 3D printed toys. So I mainly work in action figure accessories. So everything in the screenshot, other than the figure, the floor, and the wall, is stuff that I've designed using open source tools. Some of this stuff actually is itself procedural. So things like it's hard to see maybe, but there's wire shelves and wooden crates. They're actually procedurally generated, so you can have any size of that you want. So about a year ago, I came to this really awesome conference, and I started thinking about 3D printing and roguelikes. So what would that look like if you mashed them together, right? So what does that mean? There's a couple things that I think it very much does not mean. So if any of you guys, I'm sure a lot of people here are into tabletop role-playing, there's a huge amount of really awesome work going into 3D printed tabletop terrain. And that's really cool. There's a ton of really talented people making great stuff, but definitely not a roguelike, right? It's just kind of thematically related. So this is Dragonlock tiles. It's a whole set. It's very cool. So if you haven't looked into that stuff, definitely check it out. It's really cool. Getting a little closer is 3D printed board games. So this is Pocket Tactics by Adrian, I think I'm getting his name right, Croft. He goes by Dutch Mogul. His company's Ill-Gotten Games. So what's really cool about this is it's basically a 3D printable tactics game. There's a bunch of factions. Each comes with some set of hex tiles that you 3D print and some number of figures. So that each player brings their own figures and tiles. You kind of procedurally construct the level you're going to play in by laying out the hex tiles, and then you kind of have this strategic game. So that's really, really cool, but I think it's still, a 3D printed board game, right? Not really a roguelike quite. So what does that mean, right? So the things I kind of wanted to get at were single player, mainly just to distance from what might otherwise be a board game. Of course, procedurally generated, right? I also wanted hidden information, which is maybe a little harder to do with, it's something we really take for granted when you're working with digital systems, but when you go to the physical world, that might be a little more complex. And then I really wanted 3D printing to be integral to the experience, and that means a couple of things. First off, I wanted the physicality of the product to really matter. So the gameplay needed to be really tied to the physicality. And another aspect of that is I wanted to make sure that what got generated was something that really needed to be done with 3D printing. So not a stand-in for like injection molding, not just something that it would really be better if it was made some other way, something where you really need 3D printing. So what I made was this. So this is Plural, the 3D printed roguelike. I was looking for another name, but I just thought that was so delightfully weird that I went with it. So if we unpack that fully, it's the polylactic acid roguelike. PLA is a plastic, and that's what I use, which is, it's made from renewable sources, so don't feel too bad about the wastefulness, hopefully. So what this is a dungeon level in Plural. So this sort of like, if you look at the bottom row, one from the left, there's an icon there. It's a little hard to see in that photo, but that's the door where you start, right? So each one of these cells is a room in a dungeon, and you kind of kick down doors and stuff happens, right? So the way that works is, I'm going to go to this cutaway. So it's what gets generated is one object. It's one contiguous model, but here there's kind of three key components. So the base level in red here is what tells you where the exits are. So that's kind of a conventional maze-like generation, which I'll talk about in a minute. But it's not really a roguelike if stuff can't happen to you, right? So above that, there's this green layer and these blue layers. And both the blue and green layers are things you can physically pop off. So I'll show that in a minute. But the green layer is a substrate for having iconography for stuff that happens to you. So at least in this version, what that ends up meaning is there's between 1 and 6 pips of 2 different icons, either a square or a dot, signifying you either take that amount of damage or you gain that many health points back. So very simple, but I was also limited in size, which I'll talk about why that's the case in a minute. But so it had to be kind of simple. And then the blue is the door which you break off to get to the room. So this is a playthrough of a Plural level. So I'm starting by kicking down the first door, and you can see that there's exits to the west and the east. So I'm choosing to go west. It actually is easier to pop it off. It's just I was holding in a kind of an awkward way. So I'll maybe skip a little bit. So here I'm kicking down another door, and this room actually has contents. So what I'm about to get in a second is, there we go. So now there's 4, I take 4 damage. But I've dealt with that. Let's say I survived that encounter with, so there still is a little bit of a theater of the mind aspect to this, right? So everybody just imagine your favorite level 1 monster just hit us, right? So now we see that this is a dead end. So I have to backtrack. And so that keeps going for a while, and I'll skip ahead. So I kick down additional doors. In this case, there's I gain 6 points of health points. So it's a little hard to distinguish between damage and health, but that's room for future improvement. And again, you'll notice that this is very small, right? So each one of these cells is 1 centimeter, and that's for very important reasons to make the popping off work. That can be stretched a little bit, and I'll come back to that very shortly. So yeah, so I keep going, and then at the end here, I find the stairway down. So, and I would pick up another plural level, right? So how does this work? So what makes all this possible is, so far I could have just made that in Blender or Fusion 360 or any other quality 3D tool, but it wouldn't really be what we want to talk about, right? So OpenCAD is the programmer's solid 3D CAD modeler. And if it's the programmer's solid 3D CAD modeler, it must be also the roguelike developer's modeler, right? And the ProcGen practitioner's modeler. So what you can see here is it's pretty unique in that it's all about writing code to directly generate 3D models. So here's a little flavor of that. So here I'm starting with making a cube, a kind of misnamed cube because it's just a box. It can be any size. And I make another cube, and then I do a little bit more, right? So now I'm adding a translate to move the second cube up, and then I wrap everything in a difference operation to subtract one from the other. And now I've got this 3D model, this kind of like shallow tray. And 2 things that are really awesome about OpenCAD is these numbers are directly millimeters. So it's really easy to make something of a very specific size. And the other thing that's really cool about it is the output is an STL file, a stereolithography file, the commonly used 3D printing file, right? So that's basically the secret of this, right? But there are some limitations to OpenCAD. It's kind of an odd language. One of the things that's kind of strange about it is variables are all constant. So if you really want to do anything substantial, it's quite a headache. So what is preferable is there's a lot of ways to kind of use OpenCAD with other stuff. So what I'm doing for this is I wrote some JavaScript to generate the maze data. So I'm basically lifting directly from this excellent book. I'm sure many people here are familiar, Mazes for Programmers. If you haven't checked it out, definitely check it out. It's great. And if you're at this conference, you will enjoy it, I'm sure. So that's what's giving me the base maze. It was a pretty simple algorithm. It worked really great for this case because I wanted to make sure that I totally filled the rectangular grid. I didn't want anything to be given away by the shape of the 3D printed artifact. And I also don't want to waste any plastic because plastic is print time. And print time always takes longer than you want it to. So there's kind of 2 things going on. One, and here you'll see the output, right? So there's path vals, and what this is just an array of numbers, and that represents where the exits are. So I'm using a pretty simple system where it's just bits, right? So if there's a passage to the north, that's 1, and then 2 for east, 4 for south, and 8 for west. So I just get 0 to 15 represents that. And then there also needs to be, and this is what these strange numbers are, there needs to be an entrance, an exit, and various types of stuff in the rooms, right? So you'll see that there's a 1 representing the start position. At the bottom, in the bottom row, there's a 1. In the top row, there's a 2 representing the end. So all of these are kind of set up that you basically go north. You might have to figure out how to get there, but that's the general idea. And then what I'm using is, in 1/3 of the rooms, there's nothing. And another third, there's something that helps you, and another third, there's something that harms you. And help or harm is 1 to 6 points. So what I'm doing here is just 11 through 16 means it's something that harms you, and 21 through 26 means it's something that helps you. And I tweaked the generation a little bit so that the maximum range of the random value goes up as you go north. So theoretically, you make your way through the dungeon, and at first you're getting like 1 or 2 points of damage, but you might get all the way up to like 6 as you get closer to the exit. So that's pretty much it. So from there, I drop that back into the OpenCAD. So this is a little, this is the file. It goes down quite a bit, but you can kind of see up here that that's the generation, the data that was generated from the JavaScript. So it's definitely a little bit of a two-step process right now. There are ways to make it better. There's Python bindings for OpenCAD. There's also OpenJSCAD, which is a pure JavaScript version of OpenCAD, which I would like to eventually move this to, but hasn't happened yet. So that's most of it, but there's one extra little bit of kind of secret sauce here. And it's important to design for failure, right? So in order for this to work, to have that really satisfying, like popping off a door to break it down, I needed to make sure that it was printable, that would work and be solid and not too fragile, but it was also fragile in just the right place. So the way 3D printers work, so there's a lot of different technologies for 3D printing. This project is all about FDM, your typical hobbyist 3D printer. It's basically a very high precision glue gun, right? So there's kind of 2 numbers you have to keep in mind. There's the nozzle width that extrudes the plastic, which determines the X and Y resolution. And then there's your layer height. So you have to take those numbers into account, because like a typical printer is a 0.4 nozzle diameter. So you can print any multiple of 0.4 you want, but you can't print 0.5, or it's not going to work out that well. So when you have your model, you take it into this other program called a slicer, which generates paths for the printer. So this is what slice the output. So this is a preview of what your printer actually does. So this is printing a 2x3 plural level. So first we just lay down some plastic to have a base. Here we're laying down some plastic to indicate where the exits are. All pretty standard. But where it gets interesting is this next bit. So you'll see these are the supports for the contents of a room. So what I'm doing here is I'm printing up with as little plastic as I can get away with. So I'm making sure I'm using exactly 2 nozzle widths thick for these little tabs that are going up, and just a little bit across. So the other thing that's kind of tricky about 3D printing is you can't print in midair, right? Because you lay down a layer, then you lay a layer on top, and the previous layers support the next layer. But you kind of can if you're careful. So this is why all the rooms are a centimeter by a centimeter. There's a technique called bridging, where you actually do print in midair, and it can work if you don't go very far. So every printer and your filament settings can kind of determine how much of that you can get away with. So that's why all of this is tuned to kind of work. So the next layer that goes down is here I'm bridging. So those supports that were going up, I go across, and this is only like a centimeter, right? So you can basically get away with it. And I'm laying down now I've connected one direction of support, and then the next thing I do is now I lay in what supports the iconography. So that happens. I go up. This is pretty standard. So once we've got that, I just need to provide some room, right? So there's some layers that get printed just to provide some separation. And then next thing that happens is now this is bridging again to support the door, right? So you'll see that there's basically a big space, but there's 2 lines that are very thin, and that gives me something to print onto once again to make the door happen. And once I've done all of that, you kind of get these things that pop off in a pretty satisfying and fun way. And that's pretty much it. I think we might have time.